Okay, we're going to talk about percentage increases and decreases, and this actually has um, a lot of use when talking about exponential growth and decay also. Okay, so let's say that one year um, the price of something fell by 5%. Okay, and then the year after it rose by 5%. The question is, are we equal? In other words, have we returned to the same value? Okay. Well, 5% of 100. Do you know what that is off the top of your head? Yeah. If we were to decrease by, we lose $5 worth, right? So you're subtracting by $5. We're at $95 now. But the problem is this is 95. Well, a 5% increase of 95 is not the same as 5, right? So if we were to take a calculator out here, and we were to increase by 5%, so 95 times 0.05. So this tells us what the increase is. 4.75 plus 95 gives us 99.75. So we add 4.75, which is 5% of that. We're at 99.75, right? Mm-hmm. Though very close, isn't the same. So let's think of this idea like when we do, let's say we're talking about a car depreciating. Okay, a lot of times we'll say that when you buy a new car, and let's say your car at a specific point in time, maybe you bought a used car off somebody, okay? And this becomes an exponential model, usually written as a b to the kind of the power of x. And if we're talking about percentage increase and decrease, the b kind of gets broken down into 1 plus the percentage increase for growth, or 1 subtract the percentage decrease for decay. Okay, I'm talking about increase and decrease. So if we have a car that's depreciating, and A being what's called initial value. Okay. If you have a car that's depreciating in value, so say we buy a used car and the car is 5 years old, and we end up spending, $5,000 on that car. Okay, and it turns out we found out that this car depreciates by 15% every year. We want to know what the car will be worth in 3 years. Okay, so even though the car is 5 years old now, our initial value when we bought it was $5,000. Okay, so we're at $5,000. Our decay, because it's depreciating, is 1 subtract 15%, which is 0.15. Okay, and this is to the power of x. So we simplify our b here. 5,000, and when we subtract that, it's going to give us 85. Yeah. 0.85 to the power of x. Great. Okay. So this is decaying. We want to know what it'll be worth in 3 years. So our x value becomes 3. So it becomes 5,000, 0.85 to the power of 3. Okay. 0.85 to the power of 3 times $5,000. The car is now worth $30,070.62. $30,070.62. Is that what I said? Yeah. Okay, so 3 years down the road, our car's not worth very much. But the car's 5 years old. So we think back and we go, well, you know what? We want to know what the car was worth when it was originally bought. So the original price. Now, I'm going to show you how these two things differ. A common idea in this case would to go, okay, well, if it was depreciating at 15%, right? And our initial value is $5,000, then our new b must be 1 plus 0.15, right, to the power of x, which will give us 5,000, 1.15 to the power of x. And the car was 5 years old, so our x in this case is going to be 5, right, in this specific case here. But we really shouldn't be going along this because how we just talked about the year before's 15% is not the same as this year's 15%, like we just talked about at the beginning of this video here. So let's do another example where we're keeping the original formula, 5,000, and we subtract it by 15, so 0.85 to the power of x. Well, in this case, our x is no longer 5, but we're thinking 5 years ago. What would be a value for 5 years ago? If we're going back 5. Yeah, so instead of saying positive 5, we would say
negative 5.
negative 5. So let's see how these two things differ. Okay, in this case, it's 5,000 to the power of 1.15, sorry, times 1.5 to the power of 5. And in this case, it's 5,000 times 0.85 to the power of negative 5. And let's see how different our answers end up being. Okay, so I'll do the one on the left here. Do you want to do the one on the right?
Sure.
I screwed up. Did you get your number?
Yeah.
Okay, here, one second. 5. 10,056. And what did you get?
11,268.
268. And
74 cents.
74 cents. A huge, huge difference. It turns out when we do it this way, which is the way we should be doing it because that's our model, it's depreciating, so we bring it up the other way, it is actually a much more valuable car originally than we had thought if we were to just go up by 15%. Because the 15% of 5,000 is not the same as the depreciation from the original value of 15%. Okay, that's a larger amount. Okay? Does that idea kind of make sense to you, how they can be very different?
Yeah.
Yeah, so 1 year's 5% is not the same as another year's 5%. So we have to keep that in mind. So overall, no, we aren't at the original value.